Hey everybody, how you doing today? I hope you've had a good time factoring, and I hope that the techniques that you've come up with have worked for you. Today, I am going to present Elliott Factoring. I'm going to show you the exact techniques I use to solve factoring problems. And I'm going to show you, there's basically three different techniques I use. Two of the techniques I've already shown you. And my example for number one is the third technique I use for factoring, and I use Elliott Factoring for very hard factoring problems, like this one. Whoa, 6x squared plus 11x minus 35. Crikeys, that looks like a complicated one. In fact, let me just quickly show you my four examples. That's going to be number one. Number two is going to be x squared plus 11x minus 42. Example 3, 24x squared minus 26x minus 5. And example 4, 6x squared minus 7x minus 3. Let's do this. First one. Okay. This technique I'm going to use, it's kind of similar to the box and the diamond technique. It's kind of a hybrid between those two. It's a technique that I kind of came up with when I was teaching in California, and I really liked factoring by that technique. I stopped teaching that technique, though, when I learned that students liked that technique, but when they had to use the technique a year later, they didn't remember how to do it, which meant it wasn't a good technique because they didn't remember how to do it. So I stopped teaching it, but now I have kids like, hey, I still want to learn that technique. So I'm still going to show you the technique, but I'm not sure it's a good technique because you might not remember how to use it a year from now. But because you're watching this video on YouTube, you know that at least like a year from now when you're learning how to factor in your next class, or they're reviewing it, you can look back at this video again. This goes on the premise that this is an ax squared plus bx plus c equation. 6 is the a, 11 is the b, and c is negative 35. And it kind of starts off like a diamond problem. And in the diamond problem, on the bottom, I put a times c, and in the top of the x, I put the b. So I put 11 there. And 6 times negative 35, negative 210. And what we're looking for is we're looking for two numbers that multiply to negative 210, yet add to positive 11. So what are all the different ways you can multiply to negative 210? There's 1 and negative 210. There's 2 and negative 105. There's 3 and negative 70. There's 4? No. 5? Yeah. 5, 20, 42? No. 6? Yeah, it actually is divisible by 6. 6 and, oh, let's see it. 6 times negative 35 gave me the negative 210. 7 and negative 38. No. 9, no. 10 and negative 21. Hey! 10 and negative 21, that adds up to negative 11. So I know if I just switch those negatives, it would be my the right answer. So positive 21, negative 10. The reason I like this method is that when you're doing guess and check, you might go through all of the lists and guess and check, and then they'd fail. It would never ever work. It would continue to fail. So when you're running through guess and check, there's no guarantee that the problem that you're trying to solve is even factorable in the first place. But with Elliott Factoring, the minute you've filled up this box, it guarantees that it's factorable. So guaranteed factorable at this point. And if you can't come up with two numbers to fit this mold, then it's not factorable, and that's it, and you can move on to the next problem. And that's nice. Anyway, this is what we're going to do with those two numbers. I'm going to rewrite this statement here. I'm going to keep the 6x squared, 6x squared. I'm going to keep the negative 35 at the end, but in the middle, I'm going to break up this 11x to be negative 10x plus 21x minus 35. So the 6x squared stayed the same, the negative 35 stayed the same, only the positive 11x got broken up into these two terms. Then put parentheses around the first two terms, parentheses around the last two terms. And now divide out common factors, or factor out common factors out of each of these. What can you divide out of a 6x squared and a 10x? They're both divisible by 2, and they both have an x in common. What would be left on the inside is 3x minus 5. What do 21 and negative 35 have in common? They have a 7 in common. What's left on the inside is 3x minus 5. And now, looking at this, you notice how these two parentheses match? That means that you have not made a mistake, and one of the answers is 3x minus 5, and the other one is the stuff that you're kind of left behind with, which is the 2x plus 7. And to explain that step, pretty much what happened is after I factored out the 2x here and the 7 here, it's like I put a big bracket around the entire thing and asked, well, what do this thing and that thing have in common? They have the 3x minus 5 in common, so I factored out the 3x minus 5, and what would be left behind would be the 2x and the plus 7. All right, Elliott Factoring. Okay, let's move on to example 2. X squared plus 11x minus 42. Elliott Factoring always works even if this is a 1, but if this is a 1, you don't need to go through all this steps. You just treat this one the way that we did yesterday. I need it to multiply to negative 42, yet add up to 11, and then you just start going with your list. 1 and negative 42, 2 and negative 21, 3 and negative 14. It's 3 and negative 14. That's the one I'm looking for. They multiply negative 42. These add up to a negative 11, though. I need it to add up to positive 11. So I know if I just switch those negatives around, it's going to work out. So negative 3, positive 14. Guaranteed factorable because I filled out this cross. And then ultimately, it's minus 3, so x minus 3 and x plus 14. And you're done. And this, you can do this if it's just a plain old 1x squared. If there's a number up front, you do need to go through this amount of work again. Okay, now number 3, another complicated one. Yikes! 24x squared minus 6x minus 5. So because there's an a in here, Elliott Factoring does come into play. I'm going to start moving a little bit faster now. If you want a slower example, example 1 is the way to go. In the bottom of the cross, I put a times c. 24 times 5, negative 120, multiplies to negative 26, or excuse me, adds to negative 26. So let's see, 30? Yeah. So if you should always make the list. 1 times negative 120, 2 times negative 60, 3 times negative 40, 4 times negative 30. I could keep going on with the list. But once you hit a number that works, just go with it. So I have a 4 and a negative 30. I have to go through the next steps because this is a 24x squared, not a 1x squared like example 2. So I keep 24x squared exactly the same. The negative 26 gets broken into 4x minus 30x. So plus 4x minus 30x minus 5. Parentheses around the first two, parentheses around the last two. But you see this negative that's in front of this 30? You need this 30x to be negative, so include that negative 30 in the parentheses, and then you could put a plus between them. So it's still mathematically equivalent. What do these two things have in common? A 4x. So if you factor out a 4x, what's left on the inside is 6x plus 1 plus What do these two things have in common? Well, they're both negative and they're both divisible by 5. And if I factor out a negative 5, what's left on the inside is 6x plus 1. And because these two match, I know I have not made a mistake, and I end up with 6x plus 1 and 4x minus 5. Okay, that's example 2 using Elliott factoring. Let me do one more. Example 3, 6x squared minus 7x minus 3. I'm going to be honest with you. I would not use Elliott factoring for this one. There's this, because the list that things that can multiply to is pretty small. This one's either x and 6x or it's 2x and 3x, but that last term is definitely 1 and negative 3. So there's not a ton of options here. So guess and check isn't that hard of a system to go by. As I reminded yesterday, I would pick the numbers that are closest to each other first. So I could have 2x plus 1 and 3x minus 3, or I could have 2x minus 3 and 3x plus 1. Or it could be the x and the 6x with the 1 and the negative 3. So it would be x plus 1 and 6x minus 3, or it could be x minus 3 and, oops, running out of space, 6x plus 1. But when go back to my lesson yesterday, because these have no common factors, my answer can't have common factors. This 3x minus 3, those are common factors, so those are out. 6x minus 3, those are common factors, so that's out. So I really only have 2 options. And if I look at this one right here, I got the 6x squared for the first, I got the negative 3 for the last, and then my middles, I have positive 2x, negative 9x, that adds up to negative 7x. That means that one's my answer. So Elliott factoring technique isn't always the best way to go either. If the numbers are small and usable, just run through some guess and check. But even I admit, on one like this number is so large, I don't want to have to go through guess and check. And that's when Elliott factoring technique comes in handy. So if you like Elliott factoring technique, use it and enjoy it. And then next year, if you don't remember Elliott factoring technique, this video will be here. You can go back and watch it again and be like, oh, I miss Elliott videos with Cutie Kyle in the background. Hey, sweetie. I can't wait to pick you up after school today so I can show you this Mickey Mouse doll I won this morning. What? Have a great day, everybody. I hope you enjoyed Elliott factoring. And then tomorrow on Thursday, we're going to spend that entire class just working on factoring so you can become masters at it with a potential quiz. We'll definitely do our factoring quiz before vacation, Monday or Tuesday, or maybe even Friday. We'll talk about it tomorrow. We'll decide then. Have a great night. Bye. Boop.